Hi, I'm Yifu from University of Oxford. I'm a PhD student near the end of my studies here. It has been 7 years since I first arrived in the UK as an exchange student. So I will answer in this video a few questions about our recent publication with EES Solar. So question number one, can you give a summary of the work? Well, our paper presents a new method to evaluate the recombination losses at metal fingers on top of standard silicon crystal solar cells. We used photoluminescence imaging technique to find spatial variations between metal fingers, which is a direct result of extra recombination under the metal. Because these metal fingers are arranged in a 1D periodic pattern, we realized that we could use a Fourier transformation to isolate the signal at a specific frequency. We then did some device modeling to connect these periodic signals to the actual metal recombination levels. The end result is a practical way to quantify the metal-related recombination losses simply from PL imaging data. Question number two. What aspect of your work are you most excited about? We are especially excited that this approach can be applied to any typical silicon solar structure with metal fingers on one side. We don't need specially prepared test samples, which can be very tricky to make. Our method has the potential to be used in manufacturing environments. So if you take a PL image of your silicon wafers with metallization on the rear, you might spot the same periodic pattern that we are analyzing in this work. Question number three. What do you find to be the most challenging part of your research? Well, the most challenging part is got to be the analysis of the PL data. This is because the signal that we wanted is hidden behind the noises in the PL image. And I had some difficult moment trying to see what's going on between within a tiny distance between two metal fingers, and it seemed like a dead end. Thankfully, I was also learning music at that time, and I had this strange idea that if the metal fingers repeat themselves over and over again in a PL image, they just feel like the sound waves as in the music theory. And if we convert the sound waves into the frequency domain, the periodic signal will definitely show up at the correct frequency. And it kind of worked. We later found out that this is essentially Fourier transformation. And Fourier transformation is so universal that it has been applied in all sorts of science fields. So next question, what's next for me? That is a very good question. I am planning to expand this research further and find some real-world applications for it. In the same time, I'm wrapping up my PhD here, so I will be looking for a position where I can continue to work on solar cell characterizations. And that is all we have today. Thanks for watching.